Hello. Going to continue my reading of A Brief History of Time. We're still in chapter 1. Let's get to it. So we left off speaking about Isaac Newton postulating a law of universal gravitation, according to which each body in the universe was attracted toward every other body by a force that was stronger. The more massive the bodies, the closer they were to each other. It was the same force that caused objects to fall to the ground. The story that Newton was inspired by an apple hitting his head is almost certainly apocryphal. All Newton himself ever said was that the idea of gravity came to him as he sat, quote, in a contemplative mood, end quote, and also, quote, was occasioned by the fall of an apple, close quote. Newton went on to show, according to his law, gravity causes the moon to move in an elliptical orbit around the Earth and causes the Earth and the planets to follow elliptical paths around the sun. The Copernican model got rid of Ptolemy's celestial spheres, and with them, the idea that the universe had a natural boundary, since fixed stars did not appear to change their positions apart from a rotation across the sky caused by the Earth spinning on its axis. It became natural to suppose that the fixed stars were objects like our sun, but very much farther away. Newton realized, according to his theory of gravity, the stars should attract each other. So it seemed that they could not remain essentially motionless. Would they not all fall together at some point? In a letter in 1691 to Richard Bentley, another leading thinker of his day, Newton argued that this would indeed happen if there were only a finite number of stars distributed over a finite region of space. But he reasoned that if, on the other hand, there was an infinite amount of stars distributed more or less uniformly over infinite space, this would not happen, because there would not be any central point for them to fall to. This argument is an instance of the pitfalls that you can encounter in talking about infinity. In an infinite universe, every point can be regarded as the center, because every point has an infinite number of stars on each side of it. The correct approach, it was realized only much later, is to consider the finite situation, in which the stars all fall in on each other, and then to ask how things change if one adds more stars roughly uniformly distributed outside of this region. According to Newton's law, the extra stars would make no difference at all to the original ones on average. So the stars would fall in just as fast. We can add as many stars as we like, but they will still always collapse in on themselves. We now know it is impossible to have an infinite static model of the universe in which gravity is always attractive. It is an interesting reflection on the general climate of thought before the 20th century that no one has suggested that the universe was expanding or contracting. It was generally accepted that either the universe had existed forever in an unchanging state, or that it had been created at a finite time in the past, more or less as we observe it today. In part, this may have been due to people's tendency to believe in eternal truths, as well as the comfort they found in the thought that they may grow old and die, and yet the universe is eternal and unchanging. Even those who realized Newton's theory of gravity showed that the universe could not be static. Even those who realized that Newton's theory of gravity showed that the universe could not be static did not think to suggest it might be expanding. Instead, they attempted to modify the theory by making the gravitational force repulsive at very large distances. This did not significantly affect their predictions of the motions of the planets, but it allowed for an infinite distribution of stars to remain in equilibrium, with the attractive forces between nearby stars balanced by the repulsive forces from those that were further away. However, we now believe such an equilibrium would be unstable. If the stars in some region got only slightly nearer each other, the attractive forces between them would become stronger and dominate over the repulsive forces, so that stars would continue to fall toward each other. On the other hand, if the stars got a bit farther away from each other, the repulsive forces would dominate and drive them further apart. Another objection to an infinite static universe is normally ascribed to German philosopher Heinrich Oberth, who wrote about this theory in 1823. In fact, various contemporaries of Newton had raised the problem. And the Oberth's article was not even the first to contain plausible arguments against it. It was, however, the very first to be widely noted. The difficulty is that in an infinite static universe, nearly every line of sight would end on the surface of a star. Thus, one would expect that the whole sky would be as bright as the sun, even as night. Oberth's counter-argument was that the light from distant stars would be dimmed by absorption by intervening matter. However, if that happened, the intervening matter would eventually heat up until it glowed as brightly as the stars. The only way of avoiding the conclusion that the whole of the night sky should be as bright as the surface of the sun would be to assume that the stars had not been shining forever, but had turned on at some finite time in the past. In that case, the absorbing matter might not have heated up yet, or the light from distant stars might not have yet reached us. And that brings us to the question of what could have caused the stars to have turned on in the first place. The beginning of the universe had, of course, been discussed long before this. According to a number of early cosmologies in the Jewish, Christian, Muslim tradition, the universe started at a finite and not very distant time in the past. One argument for such a beginning was a feeling that it was necessary to have a first cause to explain the existence of the universe. Within the universe, you always explained one event as being caused by some earlier event, but the existence of the universe itself could be explained in the way only if it had some beginning. In this way, if it only had some beginning. Another argument was put forward by St. Augustine in his book, The City of God. He pointed out that civilization is progressing, and we remember who performed this deed or who developed that technique. Thus man, and so also perhaps the universe, could not have been around all that long. St. Augustine accepted a date of about 5,000 BC for the creation of the universe, according to the book of Genesis. It is interesting that this is not so far from the end of the last ice age, about 10,000 BC, which is when archaeologists tell us the civilization really began. Aristotle and most of the Greek philosophers, on the other hand, did not like the idea of a creation because it smacked too much of divine intervention. They believed, therefore, the human race and the world all round it had existed and would exist forever. The ancients had already considered the argument about the progress described above and answered it by saying that there had been periodic floods or other disasters that repeatedly set human race right back to the beginning of civilization. The questions of whether the universe had a beginning in time and whether it is limited in space were rather extensively examined by the philosopher Immanuel Kant in his monumental and very obscure work, Critique of Pure Reason. Published in 1781, he called out these questions, antinomies, that is, contradictions, of pure reason, because he felt that there were equally compelling arguments for believing the thesis that the universe had a beginning, and the antithesis that it had existed forever. His argument for the thesis was that the universe did not have a beginning, that if the universe did not have a beginning, there would be an infinite period of time before any event, which he considered absurd. The argument for the antithesis was that if the universe had a beginning, there would be an infinite period of time before it. So why should the universe begin at any one particular time? In fact, his cases for both the thesis and the antithesis are really the same argument. They are both based on his unspoken assumption that time continues back forever, whether or not the universe had existed forever. As we shall see, the concept of time has no meaning before the beginning of the universe. This was first pointed out by St. Augustine when asked, what did God do before he created the universe? Augustine didn't reply. Or Augustine didn't reply. He was preparing hell for people who asked such questions. Instead, he said that time was a property of the universe that God created, and that time did not exist before the beginning of the universe. When most people believed in an essentially static and unchanging universe, the question of whether or not it had a beginning was really one of metaphysics or theology. One could account for what was observed equally well on the theory that the universe had existed forever, or on the theory that it was set in motion at some finite time in such a manner as to look as though it had existed forever. But in 1929, Edwin Hubble made the landmark observation that wherever you look, distant galaxies are moving rapidly away from us. In other words, the universe is expanding. This means that at earlier times, objects would have been closer together. In fact, it seemed that there was a time, about 10 or 20,000 million years ago, that they were all exactly at the same place, and when, therefore, the density of the universe was infinite. This discovery finally brought the question of the beginning of the universe into the realm of science. Hubble's observation suggested that there was a time, called the Big Bang, when the universe was infinitesimally small and infinitely dense. Under such conditions, all the laws of science, and therefore all ability to predict the future, would break down. If there were events earlier than this time, then they could not affect what happens at the present time. Their existence can be ignored because it would have no observational consequences. One may say that time had a beginning at the Big Bang, in the sense that earlier times simply would not be defined. It should be emphasized that this beginning in time is very different from those that had been considered previously. In an unchanging universe, a beginning in time is something that has to be imposed by some being outside of the universe. There is no physical necessity for a beginning. One can imagine that God created the universe at literally any time in the past. On the other hand, if the universe is expanding, there may be physical reasons why there had to be a beginning. One could still imagine that God created the universe at the instant of the Big Bang, or at the instant of the Big Bang, or even afterwards in such a way as to make it look as though there had been a Big Bang, but it would be meaningless to suppose that it was created before the Big Bang. An expanding universe does not preclude a creator, but it does place limits on when he might have carried out his job. And I think I will leave the rest for tomorrow.